this episode, we take a networking idea that sounds simple on the surface and show why it becomes one of the most important design habits in security once an environment starts growing beyond a few devices in one open space. Segmentation means dividing a network into smaller parts so that traffic does not move everywhere equally, and so that trust can be limited to places where it is actually needed. That matters because a flat environment is convenient at first, but convenience often creates conditions where one compromised device, one misconfigured system, or one careless action can spread much farther than anyone intended. Firewall zones, virtual local area network, VLAN, design, and micro-segmentation all help create those boundaries, but they do so at different levels and for different purposes. The real goal is not to memorize three separate terms. The real goal is to understand how each one helps an organization decide which systems should be close together, which systems should be kept apart, and where traffic should be inspected, limited, or blocked as it moves between trust boundaries. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A beginner should first understand why segmentation exists at all before worrying about the mechanics of how it is created. In a totally flat network, every system often sits in roughly the same trust space, which means many devices can see or reach many other devices with little friction. That may feel efficient because people and systems can connect easily, but it also means a problem in one area can move sideways into other areas with very little resistance. If a user device becomes infected, if a credential is stolen, or if one application is misused, the path from that initial issue to other systems may be much shorter than the organization expected. Segmentation reduces that exposure by introducing boundaries. Those boundaries do not eliminate all risk, but they slow movement, narrow visibility, and force traffic to cross places where policy can be applied. This makes the environment easier to protect because not every system is equally reachable from every other system just because they happen to be part of the same broader organization. A helpful way to picture segmentation is to imagine a building rather than a network. A flat environment is like one giant open room where accounting records, lobby traffic, executive offices, server equipment, delivery access, and visitor seating all exist in the same uninterrupted space. Even if people behave responsibly, the design itself creates too much shared exposure. Segmentation is more like dividing that building into areas with walls, controlled doors, and different expectations about who belongs where. Some rooms may be open to many people, while others may require stricter access, and some may connect only through monitored checkpoints. Networks work the same way. The purpose is not to make communication impossible. The purpose is to make communication intentional. By dividing the environment into smaller trust areas, the organization can decide which systems should talk directly, which systems need controlled paths, and which systems should remain isolated unless a very specific business reason exists for interaction. Firewall zones are one of the clearest ways to express this design. A zone is a group of systems or networks that share a similar trust level, business purpose, or security expectation. Instead of creating rules system by system with no larger organizing idea, the organization can think in terms of zones such as user devices, servers, public-facing services, management systems, development resources, or guest access. The firewall then becomes the control point between those zones, making decisions about what traffic may pass from one zone to another and under what conditions. This is powerful because it moves security policy away from random one-off approvals and toward a more understandable structure. Traffic from a user zone to a business application zone may be allowed in narrow ways, while traffic from a guest zone to sensitive internal systems may be denied entirely. The zone concept helps a beginner see that segmentation is not only about splitting networks into pieces. It is also about assigning meaning to those pieces so that boundaries reflect real trust decisions. The word zone matters because it reminds us that segmentation is not just technical separation for its own sake. It is separation based on function, exposure, and risk. A public-facing website belongs in a different trust space from a payroll database, even if both support the same organization. A printer network may not deserve the same open paths as a server management network. A guest wireless segment should not be treated as though it naturally belongs near internal business systems simply because it uses the same internet connection at the edge. Zones help translate these common-sense distinctions into design language that firewalls can enforce. They also help people reason more clearly about policy because the question becomes whether traffic between two trust areas makes sense, not whether every possible system connection should be considered separately from scratch. That shift is important for beginners because it introduces the idea that good security design starts with grouping systems by trust and purpose before writing detailed rules about how they communicate. VLAN design supports segmentation in a different but related way. A VLAN allows a network to be divided logically even when devices may share some of the same physical switching infrastructure underneath. This is useful because organizations often do not want to build entirely separate physical networks for every category of device or department. By using VLANs, the environment can create distinct local broadcast domains and keep certain groups of devices separated from one another even if they are connected through the same broader switching hardware. For beginners, the important lesson is that physical closeness does not have to mean logical sameness. Two devices may plug into nearby wall jacks or nearby switch ports and still belong to different network segments because the design places them into different logical boundaries. That logical separation supports order, visibility, and security by limiting unnecessary local interaction and helping organizations map different device groups to different policy expectations. It is important, though, not to confuse VLANs with complete security by themselves. A VLAN is an important tool for structuring the network, but it is not the same thing as a full traffic control strategy unless appropriate routing, filtering, and policy enforcement also exist around the boundaries it creates. A beginner might hear that devices are on different VLANs and assume they therefore cannot affect each other, but that is too simple. If traffic is routed freely between those VLANs with broad permissions, then the logical separation exists only in a limited sense. The environment may still allow large amounts of movement between segments unless firewalls, access control policies, or other controls decide otherwise. This is why VLAN design and firewall zone design often work best together. The VLAN helps create the structural separation inside the network, and the firewall helps decide what crossing that boundary should look like. One organizes the terrain, and the other controls the gates between the areas on that terrain. A practical example makes the difference easier to follow. Imagine an office with employee laptops, voice over Internet Protocol, VoIP, phones, conference room devices, printers, security cameras, and back-end business servers. An organization might place those different device categories into different VLANs so that local traffic is cleaner, troubleshooting is easier, and devices with very different purposes are not all mixed into one broad segment. That alone improves order, but security improves even more when those VLANs are tied to meaningful zones and communication rules. Employee laptops may need controlled access to application servers. Printers may need to receive print jobs from specific sources, but should not browse around the rest of the environment. Cameras may need to send video to a management system, but should not have broad access into finance or identity services. The lesson is that a good design does not separate things merely to separate them. It separates them so that each class of system communicates only in the ways that support its legitimate purpose. Firewall zones become especially powerful when an organization starts thinking about traffic direction and business purpose together. Not every allowed path needs to be equal in both directions, and not every system inside a zone should be trusted simply because it belongs to the same general category. A user device may need to initiate a connection to an application server, but that does not automatically mean the application server should be free to initiate broad sessions back into the user environment. A server in one zone may need to connect to a database in another zone, but only through a narrowly defined service path. Good zone design, therefore, asks not only whether two areas should be able to communicate, but also who should initiate the communication, what service should be involved, and whether any broader visibility or movement is truly necessary. This is a very important beginner mindset because it shifts segmentation from static layout to controlled interaction. The environment is not made safer simply because it is divided. It becomes safer when those divisions are paired with thoughtful traffic policy. Micro-segmentation takes this idea further by creating smaller and more precise boundaries closer to individual workloads, applications, or system relationships rather than relying only on large network segments. In traditional segmentation, a zone might contain many servers that broadly trust each other because they share an application category, a data center segment, or a department function. Micro-segmentation asks whether that broad internal openness still makes sense once modern environments become more distributed, dynamic, and interconnected. Instead of assuming that everything inside one server zone should communicate freely, micro-segmentation tries to define which specific systems, processes, or application components should talk to which others and blocks the rest. This finer-grained approach matters because many attacks do not stop at the first system they reach. They move laterally, looking for additional systems, credentials, and paths. Micro-segmentation reduces those opportunities by shrinking the trust area around each workload so that compromise in one place does not automatically grant wide reach across everything nearby. A good way to understand micro-segmentation is to compare a campus with a single guarded front gate to a campus where each building, floor, and sensitive room also has its own access controls. The front gate still matters, just as traditional firewall boundaries still matter, but once someone passes that first checkpoint, the question becomes how much freedom they should have inside the environment. In many older network designs, once traffic entered a trusted internal segment, it could move fairly broadly because the environment assumed that inside space was largely safe. Micro-segmentation challenges that assumption. It treats internal trust more cautiously by recognizing that internal movement can be dangerous if one device, one application server, or one workload is compromised. For beginners, this is a major conceptual step because it shows that segmentation is not only about separating insiders from outsiders. It is also about limiting unnecessary reach inside supposedly trusted areas where risk can still spread if boundaries are too wide. Micro-segmentation is especially relevant in environments with virtualization, cloud workloads, containerized applications, or distributed business services where traditional network perimeters are less obvious than they once were. When applications are spread across multiple environments and components communicate in more dynamic ways, relying only on a few large network segments may not provide enough control. A broad server zone might contain dozens or hundreds of workloads with very different functions and sensitivities. If all of them can see or reach each other too easily, then one compromised workload may become a stepping stone to many others. Micro-segmentation helps answer that by bringing policy closer to the actual workload relationship instead of assuming the whole segment deserves the same trust. The beginner lesson here is not that old segmentation ideas are useless. It is that modern environments often need both broad structural separation and finer-grained internal controls. Security design becomes stronger when boundaries exist at more than one level and when trust is reduced to what the real business relationship actually requires. Another important design principle is that segmentation should follow business function, data sensitivity, exposure, and administrative reality rather than arbitrary diagrams. A poor design can create so many segments, zones, and exceptions that the environment becomes confusing, fragile, and difficult to manage. That kind of over-segmentation may look strict on paper, but behave badly in practice because teams start adding broad workaround rules just to keep work moving. Good segmentation, therefore, requires balance. The organization should create enough separation to reduce risk meaningfully, but not so much that nobody can understand the design or maintain it cleanly over time. This is why understanding the purpose of each boundary matters so much. If a team cannot explain why a zone exists, why a VLAN is separate, or why micro-segmentation blocks one workload from another, then the design may already be drifting away from real need and toward unnecessary complexity. Strong segmentation is not about making the environment hard to use. It is about making trust deliberate and justifiable. Several common misconceptions are worth clearing away here because they can distort design decisions early. One misconception is that segmentation is only for very large enterprises, when in reality, even modest environments benefit from separating guest traffic, user devices, sensitive servers, and management paths more thoughtfully. Another is that VLANs alone solve security, when they really provide structure that must be paired with proper traffic control to deliver full value. A third is that micro-segmentation replaces traditional zone design, when the better view is that they support different layers of the same larger goal. Some learners also assume segmentation is mainly about performance or network tidiness, but its deeper value is about limiting blast radius, reducing lateral movement, and creating places where policy can be enforced meaningfully. Once those misconceptions are removed, the design logic becomes much clearer. Broad zones set the major trust boundaries. VLANs help structure the network logically, and micro-segmentation refines protection where internal openness would otherwise remain too wide. When all of these ideas are working together, segmentation becomes a way of shaping how trust lives inside the environment. Firewall zones define major areas of shared purpose and shared expectation. VLANs create logical separation that keeps local communication cleaner and supports those larger trust distinctions. Micro-segmentation narrows communication even further when large segments would still leave too much room for lateral movement or unnecessary application-to-application reach. The result is not a network where nothing can talk. The result is a network where communication becomes more intentional, more visible, and easier to defend because each path exists for a reason rather than by default. That matters greatly in real incidents. If one workstation is compromised, if one application component is misused, or if one server is exposed, the attacker or error does not immediately inherit free movement across everything else. Boundaries slow progress, force traffic through control points, and give defenders clearer places to observe and enforce policy. By the end of this discussion, the most important lesson should feel practical rather than abstract. Designing segmentation with firewall zones, VLANs, and micro-segmentation means deciding where trust should begin, where it should end, and what kinds of traffic deserve to cross from one part of the environment to another. Firewall zones provide meaningful security boundaries tied to function and risk. VLANs help create logical network structure that keeps unlike systems from sharing the same local space unnecessarily. Micro-segmentation adds finer control closer to individual workloads and application relationships so that internal trust does not become overly broad. Together, these approaches help organizations replace flat convenience with intentional design. They do not remove every security problem, but they greatly improve the ability to limit exposure, reduce lateral movement, and make network communication reflect actual business purpose instead of accidental openness. That is why segmentation remains one of the most valuable habits in modern security architecture, whether the environment is small, large, traditional, or highly modernized.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.